Hello everyone, I'm Hema, a software engineer on the AI operations team here in the AI Center of Excellence at Red Hat. In today's video, I will be going over the KPI metric visualization notebook developed as part of the OCP CI analysis project. In this project, we aim to accelerate and improve the continuous integration or CI process of software development workflows. The CI process runs automated builds and tests of software before it is merged into a production code base. In order to measure the effectiveness and quality of our CI testing process, we need to establish the relevant key performance indicators, commonly known as KPIs. These KPIs can not only help us evaluate any AI-based enhancements we make to the CI processes, but also help us identify what are the sum of areas that require the most improvement and therefore we should be devoting our resources to. We came up with several KPIs that we believe are relevant to the various personas involved in the CI process, such as the developers, the project managers, and so on. Each of these metrics are defined in separate notebooks where we calculate and save these KPIs to our Ceph storage as Parquet files. The notebooks are available for viewing and are running on our public Jupyter Hub instance on the Operate First environment. You can also follow the metric template notebook that we've defined for calculating these metrics. And there's also a video by one of our colleagues who has done a walkthrough of this notebook as well that you can watch for reference. Some of the metrics that we came up with involved things like what are the number of tests that are blocked, what are the number of tests that have timed out, what is the total number of builds that have been passing successfully, the number of builds that have been failing, and so on. And each of these metrics, as you can see, we have their relevant notebooks defined as well. Now that we know what these key performance indicators are, let's go ahead and visualize these available metrics. Although we plan on using some external tools like Superset for visualization, we also provide the option to visualize these KPIs inside of these Jupyter notebooks so that a lot of the data scientists have the ability to explore and view these metrics before coming up with their machine learning models. To start off, we'll go ahead and import all the required Python libraries. As a best practice, we are using the Seaborn library as our visualization library, and we are setting a standard size of 15 by 5 for all of our charts and graphs. In order to fetch the data, since we're storing it into Ceph, we need to specify the Ceph access variables. And once we've established this connection to Ceph, we can go ahead and fetch all of the KPI metric data that we have inside our KPI bucket that we've created. In order to fetch this KPI data, we've created a function over here which will fetch and extract the unique names of the KPI metric files and the listed KPIs available in them. As we can see, we have a bunch of KPI metric files over here, along with the metrics that are being calculated inside these KPI metric files. For example, if we look at the test pass failure KPI metric file, we are storing 3 different metrics inside this file. One is the test duration, one is the failure, and one is the passing metric. Now let's look at a plotting function that we can invoke for each of these metrics. This plotting function is looking at taking the timestamp or the date on the x-axis, the metric values on the y-axis, and plotting it as a linear time series graph where we specify the x labels and the y-axis labels along with the plot title. Let's start looking at each of these KPIs one by one. The block timed out KPI file consists of two metrics, the tests blocked and the test timed out metric. Let's go ahead and plot these metrics to understand them a little better. The number of blocked tests tells us what are the count of the tests being blocked on a daily basis, and here we can plot these values for each day, and we see that this has been 0 for the past 3 months, that is from April to June. Similarly, the block test percentage metric will also be 0. Now the number of timed out tests gives us a count of the tests that have been timing out, and we can look at it on a daily basis. This again seems to be 0 for the past 3 months, and similarly the percentage of the tests timing out is also 0. Now let's look at the build pass failure KPI file, which consists of metrics like the number of builds that are failing, the number of builds that are passing. So we will fetch all of the required KPI files, store them in suitable data frames, and then invoke the plotting function. So here we're looking at the number of builds that have passed daily. We see that this is about 25,000 to 27,000 over time on an average, and the build pass percentage seems to be about 50 to 51% over time, seeing it to be dropped around May to about 47%. So this is the build pass percentage over time. Similarly, we plot it for the number of builds that were failing over time. We see that this also tends to be about 27 to 28,000 over the past 3 months on an average, and the build failure percentage again seems to be about 52 to 53% over time, and this indicates to us that there is a good 50-50 chance for a build to either pass or fail. Now let's look at the number of Flakes Kpi file, which consists of the flake metric to identify what are the number of tests that are flaky. So when we plot this, we see that daily the number of tests that were flaky seem to be about 20 to 40,000 roughly on an average, which seems to be quite high. And we also try to calculate the percentage of these flakes, and we call this as our flake severity, which can be used as an indication of the severity level or the overall flake rate of a test. And again, this should correspond to how often we are seeing these flakes over time. So we see that the number of flakes has increased over time, and there were more flaky tests being found. Now let's look at the percent fixed at each timestamp, which basically comprises of the metric such as percentage of tests that were fixed. And here again, if we look at the percentage of tests that were fixed over time, we see that this was about 0.17% over time. Now we move on to the persistent failures KPI, which has a bunch of metrics. The first one being the mean length of failures, that is, it keeps track of how many times the build was run before a failing test started to pass. We see that this mean length of failure was about 0.285 and about 0.255 as the minimum and maximum values. The mean time to fix is the time taken before a failing test started to pass. Again, we see that over time it has reduced, that is, the lesser time is being taken before a failing test starts to pass, which is a good indication for us. The consecutive failure rate calculates the percentage of failing tests that remain failing for more than one build, and here we visualize this again over time, and we see that on an average it was about 0.0125 as the consecutive failure rate. The pass to fail rate calculates the percentage of tests resulting from a pass to fail transition, and we obviously want this rate to be decreasing over time. However, we see that it has not really been that consistent, hence indicating there's room for improvement. Similarly, the fail to pass metric calculates the percentage resulting from a fail to pass transition. The test pass failure KPI calculates the number of tests that were passing and failing over time. Here we see that the number of tests passing was about 80 to 95,000 over time, and the test pass percentage again is reflected accordingly. We also have the number of failing tests, quite low compared to the number of passing tests, about 7,000 to 3,000, and again it calculates the percentage of the test failing. And although we see that the test failure percentage has increased over time, this is however not as significant compared to the number of tests that have been passing, which is about 70,000 to 95,000. The time to test KPI file comprises of data such as test run times, so the average time taken for the test to complete. We see that on an average it was about 88 to 85 minutes taken, and that concludes some of the metrics that we have collected over time. And as we can see here, that this gives us some insights into how these metrics behave over time. However, we can further explore and understand each of these metrics much more in an in-depth analysis. And as part of our future work, we are looking into exploring other visualization tools for further detailed analysis. Please reach out to us if you have any other questions, and feel free to contribute to our repository. Thank you again, and hope this video was helpful.